Hi everybody, and welcome back to your final online learning maths lesson. We can't wait to see you all back next week. So making sure that we're getting through this one final lesson because we're going to continue with our learning when we come back. So let's get started. So we have been adding and subtracting fractions this week. So all I want us to do is just to rewind on the methods and the steps that we have to take to add and subtract fractions with different denominators. Okay, I've given you a little clue here, keyword common denominator. So what I'd like you to do is simply have a go at adding or subtracting these fractions for me. Okay, while you're doing this, I want you to be thinking, right, what am I going to have to do? So I'm trying to drink because I think I've got a frog in my throat. I want you to think, right, how am I going to solve this? And I want you to see if you could write an explanation about how you have solved it. What steps have you taken? Having a go at those two. So if you need to have a quick look back at yesterday's, just think, right, how am I going to solve this? The steps that you took yesterday. And then once you've had a go at this, can you have a look at this, convince me? What has this person done wrong here? What have they done wrong there? What have they done? And then come on back and you've had a go at that. Brilliant. So hopefully you've had a go at that now. So let's have a go at this first one then. So I can see straight away I've got 6 8s. I'm adding a half and I'm adding 3 8s. So I can see straight away that this one is the odd one out here. So what am I going to have to do before I can add these? Can I add apples and bananas? No, I cannot. I'm going to have to find that common denominator. Okay, I'm going to have to try and get them into the same denominator. So I can see straight away that my other two are 8s. So I know that this half is going to have to be, I'm going to have to find the equivalent fraction in 8s. Okay, so I already know that it needs to be an 8. So this is going to help me to see that pattern, the relationship between my denominators. So what has happened from 2 parts to 8 parts? I've got 4 times as many because 4 times by 4, 2 times by 4 is 8. I've got 2 times as many parts now. So remember, when I'm finding those equivalent fractions, those common denominators, whatever we do to the bottom, we also do to the top. Okay, so I'm also going to times that by 4. Now, you might have done an even quicker way because you know that the pattern when a fraction is a half, the numerator is half of the denominator, 4 and 8. 4 8s. Okay, so now I've converted 1/2 into 4 8s. So let's rewrite that number sentence now with the ones that I've just changed. So 6 8s, I've changed 1/2 into 4 8s, and then I'm adding 3 8s. Now, just because there are 3 digits, 3 fractions, does that mean I can't just add them all together? No, it's just like any other addition. You can add as many as you want. Now, these are small numbers, so you should be able to just use your fingers or your head or know your number bonds, which I've just seen straight away. So 6 and 4, I know is my number bonds to 10. 3 more is 13. So I know I've got 13 of them, but I've got 13 what? 13 8s, because remember, if I was doing 6 bananas, add 4 bananas, add 3 bananas, I would have 13 bananas. That noun. So this, I'm not working with bananas, I'm working with 8s. So 6 8s, add 4 8s, add 3 8s is 13 8s. Okay, so well done to you if you got that right. Right, this one here, this one, I'm hoping that you notice is actually an improper fraction. Does that change anything about your adding or your subtracting? No, it does not. I can just do it as I have been doing all this week, just simply taking them away. But can I take them away as they are? No, I cannot, because they have got different denominators. So which one of these do we think is best to convert them to find them into equivalent fractions? 12 and 6, I know that 6 is half of 12. So if I was going into 6, I would have to divide that by 2. Can I easily divide 15 by 2? No, because it's an odd number. So I know straight away that it's this one that I'm going to have to convert into 12. So my 15 twelfths is going to stay the same. So I can write that there ready now. But what am I going to be adding? So 4 6, and I want it to now become 12. So I want to know what is that same fraction, the same amount, but different denominators. So what's happened from my 6 parts to my 12 parts? I've got 2 times as many parts again. And remember, whatever you do to the bottom, you do to the top, times by 2. So 8/12 is the equivalent of 4/16. So it's still the same amount. I'm not changing the amount I'm adding. I'm just making it so that I can add them together because they are then the same amount of parts. So 15/12 I've already got. That can stay the same. I'm going to add my 8/12. So 15, 16, 17, 18, 19, 20, 21, 22, 23. So I've now got 23 what? 23/12. Okay, now I can also show that in a different way, because I know that that is an improper fraction because my numerator is larger than my denominator. So how many groups of 12 can I make? I can make one group of 12 because I know two groups would be 24. I can make one whole, and then how many am I going to have left? I'm going to have 11/12 left. You may have written it that way. So well done to you if you got those right. Brilliant. So, okay, we're going to carry on then with what we've been doing yesterday. So it's like another lesson, because remember, the more times we do this, the more times we practice this in lots of different ways, the more confident you will become with using this method. So we're going to be adding and subtracting fractions with different denominators. Old learning, because we've already done it. So that we can apply our understanding of these equivalent fractions to solve a range of problems. Okay, so we're going to be bringing lots of prior learning and prior knowledge to help you to solve this. Okay, so let's get started then. So what are we going to have to do before we can add these fractions? So I've already given you a clue there with my explain it that we're going to be adding in this question. You've got question A and question B to have a go at. So I want you to explain first any problems that you might face. Then I want you to use it. I want you to solve the problem. So A first, and then prove it. Could you draw this diagram? Show me what you've done. Once you've done that one, again, I want you to go back, explain question B. What are you actually going to have to do? What is that number sentence that you're going to be solving? Get yourself an answer, or prove it if you need to draw your diagram to help you get the answer. And then get me an answer. I don't know what I'm talking about there, guys. I went a little bit blank for a second there. But I also want you to think about, right, convince me, can I add all three of these fractions together in one go? Okay, can I do that? Or is there another way that I might do it? Or am I not allowed to do that? Okay, so once you've had a go at those two questions with your prove it, come on back to see how you got on. I've not even read the question, have I? So the first question is, what fraction of the course has Bella run so far? So this is the information that you're using here. And question B is giving you some information about Max. So I'm guessing this is Max here. It's giving you what he did in the first 10 minutes, in the next 8 minutes, and the next 5 minutes. So don't get confused by all those different numbers there. Make sure you're zooming in on the numbers that you need. So what fraction of the course has he completed in total? Okay, so both of them are using the in total, or run so far. So they're both telling me that they're adding. Okay, have a little go at those and then come on back. Fabulous. So I'm hoping you've had a go at that now. So let's see how you have got on, to see if you did it in the same way that I did. Just trying to find my pen. Lost it. There it is. Okay, so the first question then, what fraction of the course has Bella run so far? So I need to look at this information on this sheet here, on my actual question. So it took me 10 minutes to run the first 3/8 of the course. I ran the next quarter in 5 minutes. What fraction of the course has Bella run so far? So I can see in that question that she's run 3/8 and she's ran 1/4. It wants me to tell me the total distance that she's ran so far. So I know if I'm looking for the total, the whole, I'm going to be adding these fractions together. Okay, my alarm is now ringing, ding, 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 ding. They have both got different denominators. Okay, so what is the easiest thing for me to do to turn my quarters into eighths, or my eighths into quarters? I've got that odd number on the top, so if I'm half in anything, because I know that they are half of each other, I can't really do it with ease with the 3. So I'm going to select this fraction to find the equivalent fraction in eighths. So you might have drawn this. Okay, I've got 1/4, but now I'm going to turn these into eighths. So each of these are going to be split in half to make 8 parts, and you can now see that that 1/4 has turned into 2 eighths. Okay, but I could use oh, got a hair in my mouth. I could use my method to see what has happened to my parts using the relationships of those numbers. So 4 has got 2 times as many parts. I've doubled it to 8. So whatever I do to the bottom, I do to the top, which is 2 8s, giving me the same answer. Okay, so now I'm not doing 3 8s add 1/4. I'm now doing 3 8s plus 2 8s because it's the same amount. It's just that they are now in nice, they're in the same denominator, which means it's nice and easy for me to add them together. I get my equals, and remember when you're adding, do my parts change size? No, unless I'm finding equivalent fractions, which I'm not. It just changes the amount of those parts that I've got. Doesn't change the amount of parts that make my whole. So I've got 3 parts, I've got 2 more parts, 5 8s. Can I simplify that any further? There's no relationship between 5 and 8, so no. So 5 8s of the course is what Bella has run so far. Okay, so to prove that, I could use my diagram here where I've got my 2 8s. I'm going to colour in 3 more of those 8s. And you can see 1, 2, 3, 4, 5 8s is my answer. Well done to you if you got that one right. Fantastic. So question B then. So before I even do this, I'm going to think about the convince me. Can I add all 3 fractions together in one go? So let's have a little look. 1/3, 1/6, 5/12. Can I add those all together in one go? Your convince me answer would be no, because they are different denominators, and you can't add fractions with different denominators. I need to try and find that common denominator. Okay, so 1/3 then. He ran 1/3, Max. He ran 1/3 in 10 minutes. He ran the next 1/6 in 5 minutes, in 8 minutes, sorry. And then he ran 5/12 in 5 minutes. Okay, so another question that I could have asked is how long did it take him to run this distance? You might have also figured that out. So he ran this bit, then this bit, then this bit. And it's asking me how much did he complete in total. So again, that keyword, I'm finding the total, which tells me that I'm going to be adding these fractions together. Now, what's the problem that I've got here? The other question, I only had 2 different denominators. This one, I've got 3 different denominators. Now, I personally always just go to the biggest one. That's just something that I prefer to do. You could turn these into thirds, but this numerator here is causing me a problem because 5 is not in my 3 times table. I could divide it by 2 to turn them into 6. But this one is a 5, so again, it's an odd number, so if I divide it by 2, it's not going to help me. So the best way is going to be to turn these 2 into 12s. Okay, so that's probably the trickiest thing, working out what you're going to change and why you're going to change it. So let's start with 1/3 then. So I'm going to use my method here. I'm turning them into 12. So what has happened to get from my 3 to my 12? Remember, when we're doing our equivalent fractions, we're either timesing the amount of parts or dividing those amounts of parts. So my number has got bigger, so I'm going to be timesing. How many times as many parts have I got? 3 times what is 12? It's your times table. I've got 4 times as many parts because I've got 3 times by 4 is 12. So whatever you do to the bottom, you do to the top. So 1 times by 4 is 4. So 1/3 is equal to 4 12s. Okay, that's that one done. So now I'm going to go to my 6. I'm just going to get a different pen because my pen is running out. This one then, so 6, same again. I'm going to write my 6. My pen's much better. I should use that at the start. And I'm turning them into 12s. What have I had to do? Well, my numbers got bigger. My parts have got more, they've not got bigger, I've got more parts, not bigger because remember more parts get smaller. I've got more parts, so what has happened? How many more times as many parts have I got? 6 times by 2 will give me 12. And whatever you do to the bottom, you do to the top. So 1 times by 2 gives me 2. Again, if you want to do that method of drawing it, you can. But that's where it gets a little bit tricky because you still need to know that 6 is 2 times, 12 is 2 times as many as 6. Okay, so this is probably your most efficient method. So 1/3 is equivalent to 4 12ths, 1/6 is equivalent to 2 12ths. So now what I can do is I can substitute these these twelfths into this number sentence now. So 4 twelfths, add 2 twelfths, add 5 twelfths, and then that should get me my answer. So remember, do my parts change size? No, because I'm just changing how many of them I have. 4, 5, 6, 7, 8, 9, 10, 11. Max has completed 11 twelfths of the course. Can I simplify that any further? Are there any relationships between 11 and 12? No, so 11 twelfths is my simplest form. Well done to you, if you got those correct. Fantastic. So hopefully that has brought back all of those skills that we've been doing over this last 2 days. So let's get on to some more practice. So this is use it. I want you to have a go at this, applying all that method that you've used so far. Oh, I've got one there, not oh. Change that for you. Okay, so you've got a question here where they've given you the pictorial representation already. This one here that they want you to show your pictorial representation once you've put them into the same denominators. This one here, you've got your use it. Could you create your own word problem using more than 2 fractions? Okay, so this is sort of you've really got the hang of answering these questions now. You're really confident at them. Could you create your own problem using more than 2 fractions, and your total has to be larger than 3? So there's a lot of steps that you need to hit with that one. And so really only try that one if you are really, really confident. If you're not too confident, or you're still just okay with this, don't worry about it. Okay. This one here then, first thing I want you to do is read those questions and tell me, are you going to be adding or are you going to be subtracting? So remember those key bits, so underline those key words that are going to tell you whether you're adding or subtracting. So have a go at those 3, so you'll explain it in your 2 questions. And then remember, if you are really, really finding this quite easy, you can always challenge yourself a little bit further. And come on back when you've had a go. Okay, so I'm hoping you started to realise that these questions weren't as simple as the first one that we've just done. So it's quite tricky to work out whether you are adding or whether you are subtracting. They've used their words to make you think a little bit more about it. So let's have a look at this first question. So Lewis ran 3/5 of a kilometre. Danny ran 9/10 of a kilometre. How much further did Danny run? So we're not just simply adding or subtracting. We're trying to work out how much further did Danny run. So you can see here that 3/5 is equivalent to how many tenths. So they've still got the same denominator, that common denominator. So we can see here that 3/5, I'm going to use my own method, is equal to 6/10. Can you see why it's 6/10? Because that is times by 2, so that also needs to times by 2. Okay, but you could have also used this representation here, because there's 1/5, there's 2/5, there is 3/5, 4/5, and 5/5. They've then split those fifths in half, because that will then give them 10 equal parts. And you can see that 1, 2, 3, 4, 5, 6 of them. Okay, so that's the first step. So even though the question is slightly different, you are still finding that common denominator. Okay, but now this next part then, how much further did Danny run? So if ever, we've already done this when we've been doing our addition and subtraction learning with whole numbers, how much further is the same as finding the difference? Okay, so how much further? So they've used their pictorial representations here so that you could actually see how much further Danny has run. Okay, so you could use that diagram to help you. How much further has Danny run? But I can see that there's 1, 2, 3. There's 3 more parts. So what are they? They are 3. How many parts make your whole? 10ths. Okay, but we know whenever we're finding the difference, it's the same as subtraction. So the larger number, which is going to be your 9/10, which is the distance that Danny has run. Subtract the other distance, which is what Lewis has ran, which is 6/10, will give you the same answer. So well done to you. if you got that right. It's a little bit trickier there, a little bit more steps, a few more steps for that one. So this one here, let's first put our explain it glasses on. What are they asking us to do? Lexi times how long it takes her to complete 3 obstacles. It takes her 1/6 of a minute to climb a wall. It takes her 1/4 of a minute to run across the muddy track. It takes her 7/12 of a minute to do the zip wire. How long does it take Lexi to complete all 3 obstacles? Okay, so how long does it take Lexi to complete all of them? What am I doing there? That big keyword, that big keyword is to complete all 3. I'm thinking there straight away, I'm going to have to add them together. Okay, so you can see here that they've given you a pictorial representation, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is split into 12 equal parts. So they've already given me a clue that I'm going to convert and find the equivalent fractions in 12ths. So 7/12 can stay the same, but I'm going to have to change my 1/4 and my 1/6, which is just like we did in that last question. So let's start with 6. I know that I want my denominator to be in 12ths. So that's going to help me to find that relationship and see that pattern. My parts have got more. I've got more parts, so I know I'm going to be times in, but how many times more parts have I got? 2, because 6 times by 2 is 12. Whatever you do to the bottom, you do to the top. So 2/12. So 6/12 is the same as 2/12. So in fact, I'm going to use this to help me. So let's already put on my 7/12. I know I've already got 7. So 1, 2, 3, 4, 5, 6, 7. Okay, let's change that colour. Let's do the 2/12 in red. So I've got 2 more 12ths. And then last one I need to do is the 1/4 because it's a different denominator. So I need to make sure it's the same denominator. So 1/4, again, I'm turning it into 12ths. What has happened to get from 4 parts to 12 parts? Using my knowledge of times tables, using my 4 times table, 4, 8, 12. I've got 3 times as many parts. So I'm timesing by 3. I'm timesing by 3 to the numerator as well. So whatever you do to the bottom, you do to the top. So that is equivalent to 3/12. So I can now add this to my picture. Oh. Have a look. So 2/12, 7/12, and 3/12 actually gives me the answer 12/12 of a minute. Because this is 1/6 of a minute, this is 1/4 of a minute, this is 7/12 of a minute. Remember, it's less than 1. But if I've got 12/12, that is equivalent to what? That is equal to 1 whole. So how long does it take her to complete the obstacles if all of those parts of a minute add together to make 1 minute? So my answer there, so that was just a bit trickier to work out what the answer was actually going to be, what they actually wanted for my answer. So the working out should have been nice and easy because it's just like we've been doing, but the answer was tricky to work out here because it gave me 1 whole, which we know we're working in minutes. So it took her 1 minute to complete the 3 obstacles. So well done to you if you didn't fall into that trap and you got that one correct. If you managed to get onto your Use It, please do send your problems to your teachers because we would love to have a go at answering your tricky questions. And let's get on with today's independent activities. So we're going to go back into our Power Maths book. So Power Maths Practice Book, page 74. You can see it's nothing different to what we've been doing, and they just might have shown it in slightly different ways. So what fraction of the flowers has Bella given away? So here you can see they've already given you the clue that you want to equivalent fraction to tenths. Excuse me. So you can see here they've used a diagram to help you. So 1/5 they've already shown you is equal to 2/10. You've got your 7/10 already there. They want you to show that total there. So using that bar, just like we just did with that last question, you've got the 7 and you've got those 2, how many have you got all together? And you can see that in a number sentence here and your final answer. Okay. B is what fraction of the flowers does she have left? So using that same information, what fraction does she have left? Okay, so that's like the second part of that question. Question 2, there's no pictorial representations. They just want you to convert all of them into 8. So they've given you that clue there that this 8 add this 8 is equal to this 8. And this one is also giving you a clue that you could simplify that into a mixed number. Okay, that means that this answer is going to be an improper fraction. So you can see how lots of different learning from over this last few weeks is all coming together now, and it's asking you to use lots of different skills. B, again, is a normal number sentence. So there's your two different, there's your two different fractions, ninths and thirds. It wants you to convert into ninths and then get yourself an answer. This one here, these two, it's not giving you any ideas. It wants you to have a go at converting them to whatever you want to convert them to. And the fact that it's got another equal sign after it, it's asking you for that simplest form again. So is there an easier way, a smaller number, but a bigger part that you could convert it to? So remember, 3/6 is the same as 1/2. Can you see you're trying to get that numerator as small as possible if there's a relationship between those numbers? Okay, so your fraction knowledge, multiple knowledge is coming into here as well. So that's the same for the first two. Question B, it's just giving you two number sentences to have a go at and a box to show you're working out. Question 4 is what is the total length of these strips? So you're now just using a pictorial representation to then get the working out. But then question B is how much shorter is the white strip than the grey strip? So think about that, you're finding the difference there. So what do we do when we're trying to find the difference? Okay, lots of your previous adding and subtracting knowledge coming back that we did all the way at the start of this year. That seems like a very long time ago. Question 5, what is the total of the following fractions? Explain the steps in your working. So they're actually asking for you to explain it there. So make sure you're showing those different steps that you have taken to get your answer. And then as always, you've got your challenge, okay? So missing numbers. They love to throw these missing numbers in. There's the answer. That's the fraction you're starting with. What's this one here? Okay, this one here, you're doing adding and subtracting to get a final answer. Okay, so don't fall into those traps. It's not tricky. You can just follow the same steps that we've been doing. You just might need to think about it in a slightly different way. Once you've done this, a nice little convince me to finish this week on what mistake has been made. Can you explain where they've made that mistake and what is the correct answer? Okay, we can't wait to see all of your amazing work. You've really blown us away with all of that hard work at home, and we cannot wait to see you on Monday. We're all back, smiley faces, all ready and raring to go. No doubt a little bit sleepy because we're back to getting up early again, and we will see you all next week. Goodbye.